Hello, my name is Sam McCarty, and today I'm making a video describing astatine. Now, I think probably most of you have never even heard of astatine before. I myself actually hadn't heard about it until I read the book What If by Randall Munroe. So I decided to do a little digging and found some pretty interesting things about astatine that I'm going to share with you today. First, the science facts. Astatine is the 85th element in the periodic table of the elements. It's one of the halogens, which are known to be highly reactive to other elements, and astatine is the largest, it's the most reactive of the group. Now, astatine's most stable isotope has an atomic mass of 210 and consists of 85 protons, 85 electrons, and 125 neutrons. Symbol is AT. Yeah. Now for the history. Astatine was first discovered in 1940 by Dale R. Corson, Kenneth Ross Mackenzie, and Emilio Sergei in the University of California. Its name is derived from the Greek word astatos, meaning unstable, which is actually a pretty good description of astatine. Before we get into the characteristics, something you ought to know. Most of the information that I found on astatine is just purely guesswork, and some science, some deductive reasoning. I'll explain why in a little bit. Now, it's unknown what matter astatine is at room temperature, but scientists have guessed it to be solid. Its density at room temperature is probably 6.35 plus or minus 0.15 grams per cubic centimeter. But again, this is just a guess. The melting and boiling points are also uncertain, but are thought to be at 535 Kelvin and 610 Kelvin, respectively. The color is predicted to be black, following the color scale that's true for the other halogens, but odor and binding types are both unknown. However, the information that follows is known. Asatine's oxidation states are -1, 1 plus -1 plus 1 plus 3 plus +1, +3, +5, and +7. I'll get that. The electronegativity on the Pauling scale is 2.2. Electron affinity is 899.3 kilojoules per mole. Asatine's reaction with oxygen, water, acids, and bases, and pretty much everything is instant vaporization. Which I said that that most of the information under the characteristics is just educated guesses. Reason is because hypothesis is the most reactive of the halogens. In fact, it's so reactive that and it's also a radioactive element. So pretty much every time, pretty much anything that and it's so radioactive that whenever any large amount of it is gathered in one place, it's immediately vaporized by its own heat. As the biologist, scientist Derek Lowe once said it, that stuff just doesn't want to exist. And quoting from Randall Munroe's book, What If? There's no material safety data sheet for astatine. If there were, it would just be the word no scrolled over and over in charred blood. In all caps, most likely. And actually, there is besides it being a super destructive piece of solid, it actually has some use. Nuclear medicine. However, there are several problems with that. The first problem is one that's with all nuclear medicines, since how useful they really are. Yes, they could help the person, but also give them a massive dose of radiation. Also, due to astatine, because of its radioactivity, astatine stability is pretty much absent. So it can blow. It blows up. Pretty much. So a small 1 cubic centimeter block of astatine is most likely the equivalent of a hydrogen bomb. To give you an example, with a ton of radiation. So first, it blows up the lab or your surrounding area. Then it sends radioactive fallout over the entire world. As I said, astatine is because of its extreme instability. The astatine is one of the rarest naturally occurring elements. It's the #1 rarest naturally occurring element discovered so far. And so it's about, I think there was about 6.7% in the Earth's crust at one time. Other than that, you can get it through radioactive decay. And like I said, it could be used in nuclear medicine or a nuke. Well, that pretty much concludes this video. Bye!